Hi, everyone. Sorry I couldn't attend the meeting today. I realized when I committed to going to the SWE meeting that I actually had a lab at the same time, so I am stuck there, unfortunately, at the moment. But hopefully I have one of my special projects leads there, David Moreno, and he'll be able to answer any of the other questions you might have, but I'll take you at least through our introductory PowerPoint. So I'm Scott Komar. I'm the lead engineer of the Atomic Aggies, and we are a rocketry team on campus that competes through the Spaceport America Cup. If you're not familiar with the Cup, it's a competition where teams from all over the world will come to New Mexico to launch a rocket that they have spent the past 8 months trying to launch a payload of 8.8 pounds up to 10 or 30,000 feet using a motor they've either bought or designed. So it's held out here at the spaceport itself. If you're not familiar with it, that's the home of Virgin Galactic, which you can see in the bottom left. And in the bottom right is actually a pretty large conference day. I think that was back in 2019, which was freshman year, which is the last year before the pandemic. Back then it was only 150 teams, but they've yet expanded to over 200 teams. And that includes people from all over the world, like I said, from Poland, Switzerland, Brazil, all of continental 48 states. And I don't think there's an Alaskan team, but any place you could possibly think of, there's probably a rocketry team that came from there. I'll try to actually show you the cool version of what this competition looks like. So the competition itself is usually held over the span of about a week. Usually it starts off with some kind of conference day where all the teams get to intermingle. They get to see the project works of all the other teams. You go through your safety checks, you go through your presentation of your projects. And it's a good way to really get like a bunch of different connections because there's a bunch of vendors who actually show up. So there was Blue Origin, SpaceX, of course, Virgin Galactic, a bunch of your legacy companies like Lockheed and Boeing. But anyway, once that day is over, the next 4 days are entirely dedicated to launches. We usually launch on the first day because we compete in the 10K COTS category. 10K COTS referring to 10K being your target altitude, COTS standing for a commercial off-the-shelf motor, meaning we buy ours, but we are currently developing our own hybrid system. A hybrid being a rocket motor using a fuel and oxidizer of different physical states. So our oxidizer in this case is nitrous oxide, which feeds oxygen into a combustion chamber, which has our fuel. The fuel right now usually consists of some kind of paraffin wax with different additives mixed in to get the properties that we need. This is a video of our shop currently, or was currently. This is about a year ago. Basically, this is where we do a lot of the manufacturing, a lot of the planning, a lot of the actual work that goes into this year's rocket. Right now, we're actually just finishing up the major build phase of the rocket, and now we're about to start stepping into the subscale testing and integration phase of the rocket, where now that we have all our components, we're just going to be testing things on a sub level. And so what that means is a lot of our teammates are just dealing with purchase orders, getting test plans ready. And that's all in the event of leading up to our test launch, which is usually held at the end of May. Right now, we're targeting a launch date of March 26th for the rocket itself. This will be held out at West Mesa, which is a site that's in between here and Deming. Usually we have it organized with a group called Flare, which is a group of guys organized through the National Association of Rocketry. Basically, they help us set up launch sites, help us get the logistics of a launch organized through the FAA, which is a big help just because there's a lot of bureaucratic matters to take care of when it comes to that. This is the hybrid I was talking about. Like I said, the gaseous oxidizer solid fuel, and that is a very early version of an air brake system. Right now, David himself is actually working on a new version, which is a lot simpler. It's a lot easier to use. But once again, I'm going to go through what each sub team does so you get an idea of like what all different kind of projects that are available on the team. So I'm the lead engineer. Essentially what I do is I give system requirements, and I'm more of the top-down perspective of just putting people in the places that they need to be. We have a manufacturing team which deals with the actual manufacturing of the components that go on board the rocket. So we work a lot with composite components, carbon fiber, fiberglass. You can see in the bottom right picture there, that's us wrapping a body tube to actually be used in the rocket. We have a recovery lead named Alex. He is in charge of actually getting the rocket back. Essentially, most rockets, at least in the terms of skill we use, fail in recovery. And so that's a very critical team. And it's often overlooked, but it's quite literally the most important component besides the motor itself. But like I said, he is in charge of actually recovering the rocket, making sure the parachutes deploy, setting up all the altimeters, and doing the actual ground testing to make sure all those systems work. We have our special projects lead, David Moreno, who, like I said, is working on the air brake system. Special projects itself is actually kind of an interesting group because they're not tied to one kind of singular project or mission. And so really they're just kind of the guys we say, hey, we have a problem with this, go fix it. And that's about the best we can give them. Propulsion team, like I said, is working on the hybrid motor. That's handled by Marshall Cahill and Nam Takeshita. We have our NAR group, which is handled by a guy named Ricardo Olivas. He is basically the one in charge of organizing new students who we try to get NAR certifications with. This is usually something we handle in the fall. We don't really worry about it too much in the spring semester because that's entirely dedicated to working on the competition rocket. But he essentially helps these members get the NAR certifications, which mean they can buy higher and higher impulse motors, because you don't want some random guy off the street buying a motor capable of 10,000 newton seconds of impulse. That's basically just a high grade explosive. There are governing organizations that you get certifications from that you can provide to a vendor and be like, hey, I am at least semi-competent and I can buy a product like this. We did have a student advisor in NETA last semester, but she of course graduated. So there's a lot of things I talk about where it sounds like a lot of work, and it is, but there are also a lot of benefits. Like I said, through the competition, you get all different kinds of industry connections. You actually get to meet with different representatives of companies that aren't local to New Mexico and are very aerospace related. Nonetheless, we are also the home team, which we have some ties to some very close companies like Virgin Galactic. A number of our current student members are actually part of the VG Unite Scholarship, which pairs them with a mentor who works for Virgin Galactic, as well as the stipend for the time that they've put in. We also have a bunch of senior members who have yet gone on to graduate. I myself am about to leave in May, but there are about 4 years prior worth of students who are now working the actual industry and actually having these jobs that can get you an in. Companies like Lockheed, Northrop Grumman, Raytheon, Virgin Galactic, SpaceX. I don't think Blue Origin yet, but nonetheless, a ton of companies that you might be interested in. We have people working for, so if you really want good experience and be able to relate to some of these people in these companies, this is a great team to join. There are also a lot of lessons learned, and a lot of what we learn on this team is through failure. It's not fun, it's not easy, it's heartbreaking at times, but nonetheless, we always come out better for it. So I'm just going to leave it on this slide. I've alluded to the fact that we need more people. There are too many projects on this team to handle at times, and basically I'm looking for absolutely anybody who's interested in joining. It's obviously not going to be a rapid fix. You know, the moment you walk in the shop, I might not be able to give you something exactly then, but that's just because you might not be familiar enough with the project at that moment. Nonetheless, there are so many things that we need to help with on this team. We need a lot of help with our hybrid system, actually, just because we want to move to a flight configuration of it, basically moving from this horizontal test stand that we currently have to a vertical mount, which can actually be fitted inside of a rocket. So that means taking a structure which, you know, we usually attach to this little horizontal test mount, which gives you all the space in the world, to what is usually a 4-inch or 6-inch diameter body tube, which gives you absolutely little space to work with and still having to get the same kind of performance we have been. There's also the air brakes team, which would always need help working on some of the different projects we toss at them besides the air brakes. Another thing they recently did was figured out some issues we were having with our remote ignition system. That remote ignition system is, again, for the hybrid motor, being that you don't want to start the motor standing right next to it. So we have a small box that is able to connect to it via radar frequency and be able to send a signal to open a valve, which then starts the motor. We also have our recovery team, which is actually trying to develop a system where we can recover a nose cone, which is for the payload team. And the payload this year is to launch an RC glider out of the rocket as it comes down from flight. This is the first time we've ever attempted something like this. It has opened a whole box of worms of different problems. But nonetheless, our team is actually in the middle of testing some of those components. We actually have a small mass test labeled for the end of this week, I believe. And that is definitely an area where we need help just because since it's such a new team, part of the team, it only has like 2 or 3 dedicated members that we can rely on to come and work on it. And so that is definitely an area where we're going to need help. Manufacturing itself is actually kind of bloated right now, but there's also not a lot they can work on given that we're just waiting for some of our other subgroups to get some more components for the actual competition rocket to us. And I think that takes care of most of the groups offhand. I'm going to leave it off here, and hopefully David will be at the meeting tonight, going through some of the other things that you might be interested in. If you have any questions, please feel free to reach out to him after the meeting or to me after the meeting, and so that we can get you on the team and get you involved if you wanted to help build this rocket. So thank you. Sorry I couldn't attend, but once again, thank you for your time.